We are nowadays surrounded by artificial intelligence in our phones, our computers, in our homes, in our cities, in an increasingly interconnected reality. While this has brought amazing advancements, we not only need these systems that embed AI to treat us and our data fairly, but we also need to understand how this is being achieved if we are to trust these systems. In Explain, we will create an empirical base to understand the explainability requirements that end users and other relevant stakeholders may have about privacy in AI-based systems towards improving public understanding and literacy of AI privacy and enabling users to influence how AI systems manage their data. For more information and further details, please feel free to contact my colleague Marc Cotet or myself. Thanks for your attention.
Hello, I'm Manuela Criado, and together with Jose Suk, we are going to be investigating how to allow AI systems to reason and represent and learn privacy norms. We have seen that there is an increasing use of AI systems in our everyday lives. It is estimated that 7 million users in the UK only use AI assistants on a daily basis. But we have also seen lots of examples of these AI systems not behaving in accordance with the user expectations. And that mistrust is posing a significant challenge to the adoption of the technology. So what we want is to develop a novel model to allow AI assistants to learn, represent, and reason about privacy norms. So the outcomes of the project are twofold. First of all, to develop this novel model that will incorporate symbolic AI, for example, formal representation of the norms, and sub-symbolic AI techniques on top of, for example, a machine learning method to allow these AI systems to consider norms. And secondly, we would like to apply that particular model and implement it in an open source AI assistant product as a demonstrator for the project.
Clarity will utilize text, images, videos, and the structural connectivity of social networks in order to develop sophisticated multimodal machine learning models to tackle a very real and dangerous online problem. Misinformation around health has exploded due to the COVID-19 pandemic, in no small part due to social networks. Uncountable numbers of various health-related claims are being made and shared widely across all social networks. Health misinformation has been viewed nearly 4 billion times on Facebook alone in the last 12 months. Only 16% of this had any kind of label. Unfortunately, these have very real consequences, with serious injury and significant numbers of deaths reported as a result of misinformation. While this has peaked recently, it is not a new problem. It has been reported that around 50% of British parents of children younger than 5 years old regularly encounter negative messages around vaccinations on social media. This is a problem that will outlive COVID-19. This misinformation takes many forms: text, images, videos, and it is often within the context of a social network. In Clarity, we will integrate all of these together in order to build new multimodal machine learning models that can detect health-related misinformation in whatever form it takes, and to understand how this misinformation spreads across social networks.
The analysis project will aim at producing machine check proofs of privacy and security for an oblivious computation protocol that's developed and deployed by our partner. The protocol allows a client that has secret data and a vendor who's got secret parameters in a public model to compute the result of the model on the data and release it to the client without revealing their secret information to each other. This is supported by Oblivious, produces randomness in a particular way, and distributes it to the client and the vendor so they can compute and get the result. By producing a machine check proof for this protocol, will increase trust in the protocol itself and in its implementations, which has value to a partner. We'll also be studying the feasibility of doing so at scale and considering the impact of such a proof on certification for use in government, for example.
Context project will focus on understanding the role of context in managing privacy online. Managing privacy manually is a difficult task. In order to tackle this problem, we will develop an AI-based tool that can preserve the privacy of the users automatically while focusing on context. So what is context? Context depends on many factors, such as location, people, activity, and much more. And according to various contexts, an individual may want to share some content or not. In this particular project, we will develop a formalism of privacy context, and we will be using knowledge representation and reasoning techniques for this. By using such a formalism, we will model use case scenarios, and finally, we will develop an agent-based PET that will act on behalf of a user to preserve privacy automatically.
Preserve will investigate the design of a privacy-preserving communication network for lightweight applications. The project bridges two research areas: privacy-preserving technologies, which deals with the control and protection of personal data, and lightweight cryptography, which is cryptography for constrained devices such as IoT, especially in view with the latest effort by US NIST to select new standards in lightweight cryptography to be announced in 2021. In Preserve, we will study use cases such as smart cities, smart homes, and IoT networks in general, and we will map the resource requirements in each use case to the most suitable standard in lightweight cryptography. The end goal of the project would be to propose a design for a privacy-preserving communication network employing latest standards in lightweight cryptography.
Faircrowd will develop methods to determine the value of user data in machine learning. Our data are used to make digital services better, but to find the real usefulness of our data, we need a distributed, trusted, and private algorithm that measures each contribution. This mechanism will let each person know the value of their data, and eventually it will help to provide the right compensations. The Faircrowd project will conduct research in privacy, trust, and optimization to build such mechanisms.
Query will develop a novel methodology for protecting user privacy in sequential data analysis. Sequential data are important in location-based services, marketing, and bioinformatics, where users' data are modeled as sequences of visited locations, purchased products, or genomic information. Data analysts often need to query the data. However, a malicious analyst can reconstruct the entire dataset by such queries. Our objective is to develop, implement, and evaluate a data structure that will support queries to enable meaningful data use while preventing data reconstruction.
Payment will develop methods for collecting the information necessary to protect victims of fraud, while respecting the privacy of payment system users. This topic is important because fraud is now the most common type of crime in the UK, and it can have life-changing effects on its victims. Consumer protection rules say that fraud victims should be reimbursed if the customer wasn't at fault, or if banks failed in their duty to prevent the fraud. But these rules can only work well if we know how banks are protecting against fraud, what's reasonable to ask of customers to help, and how well these measures can work. The problem is that customers and banks are not always willing to share this information for reasons of privacy or commercial confidentiality. That's why in the payment project we'll apply privacy-enhancing technologies to collect this information such that it can be relied upon for resolving disputes, while also respecting the privacy of the individuals and institutions which are contributing the data.